Hello everybody and welcome to my channel. In this video we are coming to look at Python for financial analysts. So we are coming to look at how to leverage the power of Python to undertake some financial analytics. Alright, so the objectives of this video is to first of all import the relevant libraries that are useful for our analysis, import the data from perform some exploratory data analysis on the imported data, perform some financial calculations on the data, and then finally visualize our calculations. Alright, so let's get into it. If this is your first time using Python, or if this is your first time watching a Python video, this is what we call the Jupyter Notebook, and it is an open source Python software that you can easily download on the internet. So you just go to Google and then you can download Anaconda Navigator. So when you download Anaconda Navigator, you will have access to Jupyter Notebook. Alright, so this is our Jupyter Notebook and we are coming to do our analysis right here. Alright, so now what are libraries? Libraries are a collection of functions within Python. So what we mean by that is that it is an external package that enables us to use calculations of functions that have been developed by others. So we don't have to write every code from scratch. So that is what we call a library within Python. So the popular libraries we are going to use for our analysis are, so we are going to import. All right, so let's comment. Let's do some comments. So to comment in Jupyter Notebook, we use the hash function. We use the hashtag and then we can comment. So we want to say import our libraries. So we are going to import our libraries. Sorry. Alright, so we have our libraries. So the libraries are going to import. So we're going to import pandas as PD. We are going to import numpy as np. We will import yfinance as yf, and then we'll also import matplotlib.pyplot as plt. Alright, so these are our libraries. Now in these libraries have their own functionalities. So pandas is for exploratory data analysis, is for performing mathematical functions and all that. It is also used to what you call a data frame. So a data frame is equivalent to an Excel table, having columns and rows. And then NumPy is also a library that helps us to perform mathematical functions on our data. And then the yfinance is the custom library for our analysis. It is used to, we are going to use to download the financial data from Yahoo Finance. So you have to actually pip install the yfinance. So let me just put it here. So note that you would have to install, you have to pip, it's actually pip install your yfinance in Anaconda. So it is actually so you have to pip install using the Anaconda prompt. Anaconda prompt. So, Anaconda prompt. Alright. So note that you have to pip install yfinance in Anaconda prompt. So let me put the pip install in quotes. So what I mean by that is that after installing your Anaconda navigator, you go to the Anaconda prompt. If you don't know where you find it, you just use your search button, the search function of your computer to find Anaconda prompt, and then you can type pip install. So let me demonstrate that for you. So you go to, for me, I can access my Anaconda prompt on my start menu. So I'll go to my start menu. So I'm going to start menu, and then I'll locate my Anaconda folder. This is my Anaconda folder, and then this is Anaconda prompt. Select my Anaconda prompt, and this is the Anaconda prompt window. So just give it a, so I'll just type pip install yfinance, pip install yfinance. So when I do that, I'll just hit enter, and then it will download and you will see everything. But since I have done it already, I don't need to do it again. So this is how you pip install any library in Python. Alright, so let's continue. This is just by the way. Alright, so we have imported our, so this code, run this code. Okay, let me there. So matplotlib dot pyplot as plt. Alright, so as plt. So it should run. So the start, okay, so when you run a Python code, the start there means it's still running, and now it has run, so it will turn into a number. All right, so now we want to define, let us define our, so I'll comment that out. Let us define our start and end date for the stock data. All right, so we have our start date. So we have our start date to be equal to, so our start date will be 2022 January 1st. Then our end date will be equal to 2022 December 31st. Okay, so we have defined our, then let us now so we can actually download the data here. Okay, so let's actually, so to run a code in Python, let me touch on that. To run a code in Python, I was using shift enter. When you press shift enter, it will run the code and also create a new cell below the code for you. Or you can also use the run, as you can see here. I can also just click on the run here and then it will work. All right, so let's continue. We are coming to download our data. So our name of the data frame you are coming to download, let's call it df is equal to, now I'm going to use the yfinance function library to download the data from. So I'll have yf, remember we have imported yfinance as yf, so the alias is the yf, is the alias. So dot download, and then we'll open our brackets. So we want to download the Apple stock data, so we use the ticker symbol, and then our start date, which is our start, is equal to our start date, is equal to the start date, and then the end date, which is the end date, we are using the end date. We are using the end date. So let's download let's see what our data will look like. So let's download it. So the star here means that it is still downloading, or yes, so it works. All right, so this is Apple stock data from the period 1st January 2022 to 31st January 2022. Now we can use DF. So this is 251 rows and then 6 columns of data. 251. So what that means is that we had in this particular period we had 251 days of trading, 251 trading days within that particular year. All right, so let us, instead of looking at the whole data, we can actually use the head function to look at our top 5 rows of data. So df.head, and then we can see our 5 rows here. All right, so this is our data. Then we can also use df.tail to view the last 5 rows of our data. So the head function shows us our first 5 rows, whilst the tail function help us to have a look at our last 5 rows. We can also customize the head function by, we can actually make it 10. So instead of 5, we can view 10 of the data. So I'll just put 10 in there, and then this is 10. So we have our open price, the highest price for the year, the lowest price, the close price, the adjusted close, and then the volume of trade. So this is the data we have pulled from Yahoo Finance. Now let's look at what we can do with this data. So they're looking at the head, the tail, and all that is what we are calling the exploratory data analysis. So we are trying to explore the data and see what our data contains, what we can do with the data. So we can also use what we call the df.info function, and that will give us the kind of information or the kind of data contained in each column of our data frame. All right, so we have our open, and then we have no null. So there is no null value within our data set. All right, so and then the kind of data type is float. A float number in, or we call it a float or integer. Okay, call it a float or integer. A float is a decimal value, whilst an integer is a whole number. Okay, yeah, it's a whole number. All right, so that is it for info, and then we can also look at some statistical information of our data using the function df. So the df is our data frame. Remember, the df is our data frame. So you can use df dot describe to look at some summary statistics of our data. Summary statistics. So let's look at that. So we have our count, we have the mean, we have the standard deviation, we have the mean, a minimum number, we have our 25th percentage, 25th quartile, 50th quartile, 75th quartile, and then so the 25th quartile is also known as the first quartile, the second quartile, the third quartile, and then we also have the max. So for open, so each of the columns have these. So this is the standard deviation. This is the minimum value for our open. So this is how we calculate for summary statistics in Python. All right. So this is just a quick view of what statistical information we can derive from the data we pulled from our Yahoo Finance. All right. So we can also see if there are any repeated values in our data by using what we call the n unique function. So I can also say df dot n unique, and we'll see that. So we can actually run it. So we have open containing 247, high 243. So what this means is that we have a few number of uh, repeated figures within our data, and it makes perfect sense because we cannot have in a year we can have our open price repeating because the price is always down and up, and so we can have two prices repeating on a different day. So it makes perfect sense. And then the volume traded happens to be unique, so that one we don't have any duplicates. All right, so that is just by the way. So in case there are actual genuine duplicates which we have to remove, then we would use functions such as drop na, drop duplicates and all that. But since we don't have duplicates in our data, we are going to continue. All right, so this is how we actually do some quick exploratory data analysis in Python. All right, so let's continue. Then the next thing we want to do is to calculate our returns, the daily returns. So what we do is df, we want to add a new column to our data frame. So we have df, and the data frame we want to return is returns. Let me actually get capital here. So we have returns, and this will be equal to the actual price for today is the close price. So we have our close, and we want to look at the change, percent change, and multiply that by 100. And then what we can so we have that, and then what we can also calculate from this is we want to look at our moving averages, the moving average. So we want to look at the 50-day moving average, or a 200-day moving average, a 150-day moving average, or something like that. All right, so let's do some other ones. So we want to add a 50-day moving average, a 50-day moving average. Sorry, 50-day moving average. Close this, and that should be equal to the we have still our close. We have our close price, which is our actual price. We have our close price, and we want to do it rolling. So we use the rolling to actually find our moving average. So we have rolling, then we have window equals 50. So and then we want to find the mean of that, and then you can copy this and do the same for another moving average. So let's copy that, and then paste it. Now instead of 50-day moving average, I want to do a 200-day moving average, and the window will change to 200. So the window is 200, and we have that. And then we can also calculate for volatility, which is a popular concept in finance. So volatility is talking about the risk, how risky a stock or a bond or a share is. So we have volatility. Volatility and that should be equal to the same. We have this, so I'm going to delete this. I've pasted. Okay, we have df close windows, and let's make it 30 here. And instead of the mean, we want to look at standard deviation, because standard deviation is a measure of volatility in finance. Okay, so we can perform these calculations. So let's run this. Okay, so we have a couple of errors here. Let's see what does a series update has no attribute per, sorry, direct per change. It's supposed to be percent. It's supposed to be PC. So that should be, so that is Python for you. PCT change. So that is percentage change. It's supposed to be percentage change. So let's run this again, and it runs successfully. Now let's look at our data frame, and then we see that all these new columns should be added to our data. So let's say df dot head, and then let's run that, and then we now have our new data being added to the data. So we have open, high, low, close, adjusted close, volume, returns, 50-day moving average, 200-day moving average, and then our volatility. Okay, so that is a very quick way of making some calculations. We can actually separate these in different cells, but I decided to put everything into one cell and then run it. Okay, all right, so let us see how we are going to visualize this data. So to visualize data, we'll just write, we are going to use the matplotlib.pyplot to plt, which is the alias for our matplotlib. Then we have plt dot figure, have our figure here, and then we want to set our figure size. So our fixed size to be equal to 10 and 6 for the start. So we have that. Then we want to set some, so we have our plt dot plot, and then we will have our df dot index dot index, then we have df, we want to put our adjusted close price. So we want to have our close price there, and then we want to label it equals the closing closing price. Okay, so actually we are going to plot the close price there and then the two moving averages. So I copy this, let's copy this. So only a few things are going to change. So instead of close, I'll have my 50-day, my 50-day MA, and that is going to be 50-day moving average. this, copy that, and I can paste it here, and then instead of 50 I'm writing 200 day moving average. Alright, so I can now do plt dot show, so we are supposed to put this in brackets, then let's show. It was never closed. Okay, let's run that. Alright, so just as I had said, when you are writing a Python code, you have to be very careful with your entries. So my close was a lowercase letter instead of an uppercase C, and therefore it has returned an error telling me that the key error, as I can see here, the key error is the close. Alright, so let us run that and see. So let's run it again, and then we have our moving averages right here. Very nice, very simple, very simple. Okay, now we want to, now we are just looking at the diagram. There's no information on it, so let us try to refine our graph. So we want to set the labels. We can label the y-axis, the x-axis, our give it a title, and then also insert a legend. So let's see how I can do that. So you can see that our plt dot y label dot y label to equal to, so our y label is the price. Let's write price there, and then we can also set plt uh, uh, our dot x label, and that we can set it to be date. This is actually date, so let's make it date. This is actually date. Let's look at it. Yes, so this is our date, so it makes sense that we make date there. And then we can also set plt dot title, and we want to give a title. What should we give it? So we can say our price chart, price, let's say chart of price against, so against moving averages, and then let us also show our legend. So plt dot legend, so that we know which line refers to the price, which line refers to the 50-day moving average, and which refers to our 200-day average. So let's run this. Still have an error. Okay, so I didn't actually write my y label, so let us run that again, and there we have it. So we have a nicely nicely labeled charts. So from our charts, we know that this is the title chart of price against moving averages. So the blue color is actually our closing price. It's actually our closing price moving downwards throughout the year. Then the 50-day moving average is the yellow, and then the 200-day moving average is the green you see here. All right, so this is how we can do financial analysis in Python. This is just a brief overview of what Python can do when it comes to financial data analytics. Okay, so this video actually assumes that you have the basic knowledge of Python. So in case you don't actually understand some of the codes we used in this video, I encourage you to watch other videos on Python basics, and then you can come back to watch this video so that you can really appreciate whatever we have done in this video. So I'm sure we have fulfilled our objectives for the video. We have imported the relevant libraries. We have imported the data from Yahoo Finance successfully. We have performed some EDA on the imported data. We have performed some financial calculations on the data. And then finally, we have visualized our data, and we can make meaningful predictions, analysis on the data from the visualization. All right, so thank you very much for watching the video. I hope you like it, and I encourage you to subscribe to the video, like it, comment, and then I'll see you again in the next video. Thank you.